Hello there, my name is Adeyemi Oluwaseun, and I'm here to explain to you the working principle of my Swarm Robotics project. I acquired this kit from the Skype Labs education website, and I will be explaining to you how this project works and my experience gathered while putting this together. Thank you. I was taught how to demonstrate the autonomous interaction between two robots, a leader and a follower. Here the leader follows a line and the follower replicates the same movement as the leader without having its own line to follow. So it's a pretty interesting project, and let's see how it works. Swarm Robotics is an approach to the coordination of multiple robots as a system. So basically what that means is in this project I will be demonstrating the autonomous interaction between two robots. For it to be a swarm there has to be a minimum of two robots, that's just a singular system. So right here I've got my two robots. This is my leader, and you can see it's got its sensors for detecting the line, and this is the follower. You can see it has minimalistic circuitry because it's not really doing much, just following the leader. Yeah. Back to this. Okay, so let us discuss the working principle technically of the leading robot, the master. Let's check out what components it has on. Let's start from the top. We can notice it features a breadboard for expanding connections. This is the Arduino Uno. This right here is called the L293 motor driver. It's used to provide ample power to the motor, that's the wheels. As the power output from the Arduino is not high enough to drive the wheels efficiently. Right here we have our RF transmitter module, and this device right here communicates to the follower robot what our master robot is currently doing, and our follower robot knows what to do with that information, as we would see in time. Here we've got two IR sensors. These are to sense when the robot comes across the black line. So yeah, this right here is called a caster wheel, and it is used for universal motion. Over here we've got two motors, one controlling the left and one controlling the right. So how this robot moves is based off the polarity of either one of these wheels. So if you want to make the robots go forward, both wheels will rotate in the same direction, and the reverse case would be for backward. And yeah, you would understand the working principle of the robot more as we dive into the code, but for now let us explore the connection and see. We started on by putting on three components that are Arduino Uno, our RF transmitter, and our L293 motor driver. Those are the most basic components you need first. The Arduino Uno is like the powerhouse. It's the computer behind this entire project. This project could not work without the Arduino Uno. It's the brain of the project here. The Arduino Uno features an Atmega A328P microcontroller. So let's see the connections. Here is the motor driver, and it is connected and interfaced with our Arduino Uno here. Like we said, it's the brain, so every component here is somewhat connected to the Arduino Uno. the enable pins, these are motor driver has to enable pins for controlling two different motors, enable pin A and enable pin B. Those are connected to the positive terminal of the Arduino Uno. Then we've got input terminal A1 and input terminal A2. Those terminals are used for controlling the right motor driver, the right motor right here. And it's the way it works is one input is for one direction, the other input is for a reverse direction. It's crazy. We have our ground, which is connected to the ground terminal of the Arduino. Same thing goes for the input B and the input B1, input B2 for the left motor reel. We have here our RF transmitter. In our with our RF transmitter, it has an addressing box, which is used to tell receivers nearby that this is where I'm broadcasting from. So if we want to receive from this particular robot, we have to set the receiver module on our follower robot to have the same address. Here we have our positive terminal, our ground, and then analog input B0 to B3. I didn't mention before, but then we have digital inputs A1, A2, B1, B2 on our motor driver on here. Our RF transmitter is also interfaced with our Arduino. As you can see, this brown, red, yellow, and orange cables go to the 4, 5, 6, and 7 pins of the Arduino Uno. The R sensor is used to detect light, changes in light, and uses that data to control the direction of the robot. We have two of them so we can control whether the robot goes left or goes right. It has 4 inputs, but we utilize only 3 of them because we're working with the analog output of the R sensor and not the digital output. So that's the analog out right there, the digital out, the ground pin, and the power, the 5 volt pin. This right here is a variable resistor used to vary the degree of sensitivity of these RF sensors. The same thing we have over here, and these 2 RF sensors are interfaced to our Arduino module here, as you can see. They are interfaced to our analog out inputs of the Arduino. So our breadboard here was just used to manage the power connections of our different components. So along this line is the ground, and along this power line is the positive, or along this power line here is the positive or 5 volt terminal. It supplies power to all the other components. This right here is used to connect a 9 volt battery to the motor driver to provide the extra power needed to drive the robot. This here is for a UART interfacing cable for downloading your Arduino sketch onto your robot. It also features another terminal for powering your Arduino Uno. Thank you very much. Here we defined the terminals B1, B2, B3, B4 on our RF transmitter to be pins 4, 5, 6, and 7 on our Arduino Uno. In our void setup, we set up the baud rate to be 9600 baud, and we defined our pins 10, 11, 12, and 13 as output pins on our Arduino Uno. 10, 11, 12, and 13. Those are pins connected to our motor driver. that's our A1 and A1, A2 and B1, B2 of our motor driver, and that is what we use to control the direction of our robots. Then we have B1, B2, B3, B4 here as outputs, like we said here. That is the Arduino connecting to our RF transmitter, and that is where it's going to send the data through to our slave robot. We have pin mode A0 and A1. A0 and A1, those are our analog inputs from the IR sensors, our infrared sensors for detecting the line. We come here and you notice that we learned to create an extra class, a new class called Move Robot. So this class is just used to define what the robot should do when some certain instructions are called, like forward, backward, left, right, stop. In forward, we see that we tell the robot that it should it should move the right wheel clockwise and the left wheel also clockwise, making it move in a forward direction. For backward, we see it's just the reverse. We're moving the left wheel backwards and the right wheel backwards. That's the counterclockwise direction. For the motion left, we see that on the right wheel, the right wheel turns clockwise, while the left wheel turns anti-clockwise to get a left turn, and we'll call this function with this left. Yeah. Then on right, it's just the opposite of left. The right wheel goes anti-clockwise, the left wheel goes clockwise, and it's called with the keyword key phrase right. For stop, everything is just turned off. No wheel rotates, it just comes to a stop and it's called by the function stop. Now in our void loop, this is where we set up our code to run repetitively. You will see that we initialized right and left to go to analog pins A0 and A1. Basically, this piece of code here is just going to send the information to our transmitter. This piece of code here is for printing information to our serial monitor, which is up here. It's not going to print anything because it's not going to open up because my Arduino is not connected at the moment. And here are the conditionals we've written for the motion of our master robot. You will notice that I used a right and left. So this right and left are what we've called from here. Right is the right IR sensor, left is the left IR sensor. So if right and left, if both IR sensors are greater than 500, that means we've detected a white surface. That is for where I'm at, there isn't a lot of luminous intensity, so the numbers here are going to be relatively low. So if both sensors detect a white surface, what should it do? It moves the robot forward. But not only does it move the robot forward, it writes this to our RF transmitter, which is the conditional for moving the robot forward. So this conditional is what is sent to our RF receiver on our slave robot, and is then used to tell the robot to move forward. And as you can see, it's a very similar syntax to the rest of the motion for right. So if it detects a black line, That's if both sensors detect a black line, the robot will come to a stop. Then if the robot... Jesus Christ. Now let us dive into what the circuit connection for this follower robot looks like. So like I said, it has very minimal circuitry because it's not doing much, it's just following, it's just receiving information through this guy here, passing that information to our brain, the processor of the second robot, and executing that with the motor driver. So like I said, if you look at this, you'll see that the memory address for the receiver, this is our receiver module, it receives whatever information it transmits from there onto this module here. This module now passes that information to our Arduino, as you can see. It passes it through distant analog inputs, analog digital inputs. Let me just do master. You can see how everything is off, more or less. It's the same thing we have here. If you were to change either of them, the robot would not communicate. Alright, so like I explained severally before, this passes data to the Arduino Uno on what the master is doing. That data is now being processed and has now been told to our motor driver, okay, repeat this same movement that has been done by the master robot.